So it feels weird at first that we take this kind of arbitrary collection of relations and say, okay, these ones are going to be the functions, and we're going to throw the rest of them out. What is special about a relation in which each element of the domain only appears once? Well, if we have a relation like that, if we have a function, we can think of the function as representing some rule that takes an input from a domain and gives us an output from the range. We can think of the function as some sort of a process that our variable value undergoes. And we can write, where r is a function, this notation r parentheses x, which we read r of x, to indicate the value of y such that the pair xy is in the relation R. And so we can think of this as, if you give me an x, I can dig through my relation R and find that one pair that has x as the first entry, and I can tell you what y it goes with. So let's just look at an example of how we use this notation. Here we have a relation R, and we're going to double check this is a function. And then we're going to use this r of x notation. So how do we know that r is a function? Well, look at the elements of the domain. We have -7, 0, 1, and 5, and each of those only appears once. Each element of the domain only appears once, so we know we're looking at a function. To find r of 1, we look for a pair that has 1 in its first entry, and we find it here. So 1, 7, 1, -7 is an element of R. And so R of 1 indicates the Y value at that point, -7. R of 1 equals -7 because the pair 1, 7 is an element of R. When we want to find R of -7, we look for a pair that has -7 in its first entry. Right, -7 in the second entry doesn't help us. -7 in the first entry, we have this pair. So because the pair -7, -8 is an element of R, we say R of -7 is -8. Okay, last one. Here's something weird. We're asked to find R of 4, but looking at all of our first entries, none of those is 4. We would describe that by saying that 4 is not in the domain of R, or in notation, 4 is not an element of the domain of R. And since 4 is not an element of the domain of R, how do we take the value of y so that 4 comma y is in R? Well, there's no such value. What we say is R of 4 is undefined. So if we have a number that's not in the domain and we try to apply the function to that number, we can't. And so the result is undefined. Okay, let's see another example where instead of being presented as a list of pairs, our function is presented as a graph. Here is the graph of a function that we're going to call lowercase g. And looking at this graph, we see that this is a function because it passes the vertical line test. So anytime I draw a vertical line, it only ever crosses the graph once. So g is a function because it passes the vertical line test. And now we can use this graph to evaluate the function, to find out what value of y goes with a particular value of x. So if we want to find g of 3, we'll locate the 3 on the x-axis. We'll find the single point on the graph that's on that vertical line. So we see that the point 3, negative 1 is on the graph. So in other words, the pair 3, negative 1 is an element of our relation g. That means that g of 3 is negative 1. When we want to find g of negative 4, again, we find the negative 4 on the x-axis. We find the unique point on the graph that's on that vertical line. And we see that this is the point negative 4, negative 1. So that tells us that the point negative 4, negative 1 is an element of g. In other words, g of negative 4 also happens to be negative 1 by coincidence. Now something weird happens again when we try to take g of 2. We find the 2 on the x-axis, and then we look at that vertical line, and what we discover is that actually there's no point on the graph that's on that vertical line, right? Those two empty dots do not represent points on the graph. And so what we see is that x equals 2 is not in the domain of g. Right? 2 is not in the domain of g. And therefore, g of 2 is undefined. There is no y value that goes with the x value 2 because there's no point on this graph that has x coordinate 2.